Okay, and he says he just purchased a Bassman head. It was shipped with a 45-548 twin output transformer that he understood was connected to 112 on a tone ring at 8 ohms. And it seems that the 455-48 output transformer was used randomly on these early Blonde Bassmans. Obviously, the twin is 4 5881s at 4 ohm using that same output transformer. He says, I originally connected the head to a 212 bottom wired for 8 ohms. It sounded good. Then I connected another 8 ohm 12 inch to the extension jack, giving him a 4 ohm load, and it was like a different amp. Lots of clear bottom and just so toneful. I think the later 6G6A and B used 212 cabinets at 4 ohms. The difference in sound with the extension cabinet at 4 ohms from 8 ohms is amazing. The Vibrasonic 6G13A shows the 455-48 as an 8 ohm option, but it's 4 ohm on the twin. Okay, now there's a reason for this, and also he wants to explain the 70K tap on the treble knobs on the 6G series amps. There's a reason for this. I'm going to pull that schematic up again. Yeah, okay, now you got to think in terms of turns ratio, okay, because transformers are wound to a specific turns ratio. And you can take a twin transformer that's wound for 4 ohms and 4 output tubes, and you can run it with 2 output tubes and run it at 8 ohms, because it's all a matter of turns ratio. Now, Lee, you're in my correspondence course. Have you gotten to the lesson on transformers yet?
Yeah, I just sent you lesson 18.
Yeah, that's right. So you've already done the transformer. So you know that it's the turns ratio is what's important. And now, of course, if you had the right turns ratio for a small amp and it was a small wattage transformer and you try to use it on a big wattage amp, that wouldn't work because it'd be so much current that you heat up the transformer and blow it up. But you could take a twin transformer, let's say, that you normally would run at 4 ohms, and you could put it in this Vibrasonic with 2 output tubes, and then you could run it at 8 ohms. Because when you do the math, in fact, let's do the math real quick and just demonstrate this. Let's say that a 4 ohm output transformer, you're running it, say, at 2,000 ohms. So say 2,000 ohms, you want to find the turns ratio. Well, you just divide the 2,000 ohms by the 4 ohm output and find the square root of that, and that's your turns ratio, 22.36. And we said that is, let's see here, let me find a scratch pad or something to write on.
But the Vibrasonic shows on the schematic that at 16 ohms, a certain transformer, the 45-550 for 16 ohms and the 45-548 for 8 ohms. Is that him just saying, well, I don't know.
It's all about turns ratio. So you're 45-5, what's the number of it? 45-5?
48. 48. 555 48. 48. Hey, there you go.
Okay, that one, they're using that as a twin for 4 ohms, but they're also using it as a Bassman for 8 ohms.
Right.
And they're using it as a Vibrasonic
for 8 ohms.
For 8 ohms. Okay. Well, your Bassman, we just did a turns ratio test a minute ago, and I forgot what the amount was.
22 something.
We'll start over again. Okay. Okay, the Bassman for 4 ohms. Usually a Bassman's run at 4,200 ohms divided by 4 equals the square root. That ain't the square root. The square root. So it's a 32.4. So a Bassman's 32.4 turns ratio. Vibrasonic is going to be the same. Now, if you took that same transformer and let's say you had 32.4 squared, and you multiply that times your impedance, 4, now that came out to 4,200 ohms. Well, maybe this, let's see. What am I doing wrong? I'm doing something wrong here. The 4,200 ohms is about right for a Bassman. Let's see, 4,200. Oh, I divided it by 4 a minute ago. We're talking about running at 8. Divided by 8 equals, and then you find the square root of that. Okay, so it's a 22.91.
Turns ratio.
Turns ratio. And then
so 23 to 1.
Yeah, 22.91 to 1. Yeah, almost 23 to 1. Okay, now if you took that same transformer, and let's say you ran it 4 ohm, well, you would take that and square it, which gives you the 525, and then multiply that times 4 ohms equals 2100. So that same transformer, that 22.91, I did that wrong, 91 transformer, the twin, when you run it with 4 output tubes, it's 2100 ohms running at 4 ohms. But when you run at 8 ohms, it's 4200 ohms. See? And of course, if you wanted to run it, let's say you were going to run it 16 ohms. If you ran at 16 ohms, it would be 8400.
Okay.
Primary, because your ratio doesn't change. It's like a, it's like an equation where if on one side of the equation you got your speaker, and on the other side you got your primary impedance for your tubes. And since the ratio doesn't change, if you change one side, it's going to change the other side. Just like on an equation, you multiply both sides times 2, you're going to get a different, number. So that's what they were doing, is they were using apparently that transformer is probably, an 80 watt or 100 watt transformer.
Yeah, it's a beast.
And they were using it on, different impedance amps depending on how many tubes they were using for the power tubes. And, I did the same thing on my jazz amp.
Right.
I built a, jazz amp. I wanted that jazz amp to be real robust and real clean and, have a big bottom and all that. I took a twin size transformer, one that we would use on our 4212 amp, which is huge. I mean, it's got twice as much core stack as a blackface twin. I mean, this thing is huge. It's probably 4 or 5 inches thick. And I used that for 2 output tubes, but instead of running at 4 ohms, I ran at 8 ohms because I was only using 2 output tubes and I wanted to have a reflected primary impedance of 4,200 ohms. And the thing is clean, 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 clean. I mean, it's just very, very clean. It works perfect for jazz. So yeah, and see that Vibrasonic, they were using that one mainly for steel guitar. That was their steel guitar amp. So that would make sense that they would take a twin output transformer
Right.
and run it 8 ohms. So you'd have that huge, robust amount of iron in there. And, also the twin is going to be wound with thicker wires. So you're going to have less copper loss. It's going to be faster. So,
So
yeah.
what about running the basement at 4 ohms?
Yeah, well, see, they didn't use that same transformer for the 4 ohm Bassman.
No, but I'm saying the basement that I have, I've got it hooked up with 4 ohm, and it
Okay, yeah.
sounds better.
And
Is
that's
it a problem?
well, you're going to wear your tubes out quick because that only has 2 output tubes, right?
Yes, got two
Yeah.
5881s, 2 of them.
And you're running at 4 ohms. Well, when you run it
Yeah,
at 4 ohms, you're doing the same thing what this twin is doing over here. The primary impedance that the tube sees is
okay.
now
So that
2100 ohms. Now 2100 ohms is halfway between where basements normally are, the 4200 ohms, and a direct short. It's halfway in between. So it might be louder. It might be a lot louder because it's going to draw twice the current, or it's going to want to draw twice the current. But your tubes are going to wear out pretty damn fast. And I know this because the very first amp I ever built, I had a switch to switch between 2 output tubes and 4 output tubes. And while I was building other amps, I had that thing powering a big speaker and I was listening to music, and man, it was so damn loud. I cut 2 of the tubes off. And I'm out there working, every day after work. I'm in my little barn working and listening to music and working. And when I started with that amp, I have 4 tubes that match perfectly. And after about a month of playing them like that every day, part time, with just using 2 of the tubes, I took those tubes out and tested them. And oh my God, man, they were so far off. The 2 that I'd been using, they had hardly any output left compared to the 2 that weren't used. So I know it's going to wear the tubes out quicker. I know that from, personal experience.
right.
But,
Well,
hey, if you like the
but
way it sounds, screw it. Just buy some new tubes every time.
yeah, I love the way it sounds, and but anyway, well, yeah, it's always going back to basics with this stuff. It never not. It's like going back to this turns ratio. I never even thought of doing that, and this is exactly what I needed to see. Thank you.
Cool. Okay, and then the other thing we were going to look at that you had talked about.
Yeah, the 66. The way they isn't it on the power transformer? I don't remember. It's been a couple weeks since I sent that to you. The treble knobs.
Yeah,
Oh, the tap on the treble
the
knob.
70K
Yeah.
tap on your treble knob. Okay, well, let's take a look at
Yeah.
that. Now, for some reason, this thing is not letting me use my mouse. What am I doing wrong? Must be. Okay. No, that isn't the one we wanted to look at. I got pictures that you.
Right. I sent you some pictures.
Let's see here. Maybe this is it. No. No, you did. You sent me some pictures. I remember
Yeah.
seeing.
Let me. I've got them here.
Oh, here it is, right here.
I can,
Here it is. I found it.
okay.
Okay.
All right. There you go.
So the question was, what's going on here with these tap treble controls?
Oh yeah.
And
Right.
they use these on a lot of the blonde and brown, the brown face amps, the 6G series Bassman, the Concert, the Twin, the Pro, the Bandmaster, they all use these tapped pots. And so let's take a look at what's going on there. There's a tap here at 70K. And to figure what's going on with this, let's use what I call, I don't know what I call this.
Equivalent circuit.
Yeah, equivalent circuit. Let's say that you got this wiper up here. Let me do a different color where you can see it. Or even better yet, let's blow it up.
But these are pots with another terminal on them, right?
Yeah, they got a tap. There's a tap on it.
Okay.
Okay. So let's do what we call the equivalent circuit analysis. And we will start off with a, let me get a different color here, maybe red. Okay, let's just pretend that the pot is set here. Well, if that's the case, the tap is not going to make a damn bit of difference, because you still got 180K resistance between the tap and where you're taking the signal from, and the signal you're getting is going to be mostly high end because it's coming through this little tiny 250 picofarad cap. So you're not going to do much there. But if you moved it, let's say you moved it to your wiper to here, right to the part where the tap is, then your signal, you're going to have a little bit more. I mean, you'll have the most bass you can have, but you're not going to have that much treble. And then if you go past that point, let's say you go down to here, it keeps taking treble off, because now your signal is going, I mean, you got this cap going straight to ground. So you're taking the highs off completely there.
Right. Right.
So it's just giving the pot more range. Now, you could probably simulate this by just using a 250K pot, and right here on the end, have this be the pot here, and then on the end just put a small resistor like a 30K. What's the standard value? 32K is the standard value, I believe. Put a standard value resistor there with a 0.05 going to ground, and then you just use a 250 pot, and you could simulate that if you couldn't get one of those pots. These controls are they've got a lot of range on them, more so than most, because it actually takes some highs off if you go down here below, past the tap. I mean, you're going to lose a lot of high end there with that 0.005 going to ground. So, anybody got any comments on these tap pots? I think there's some people making them if you need one, but I don't know who.
Would you explain again how you would add that? Where would you add that resistor? Where at? Just.
Well, if you were gonna replace that, let me just draw it out here real quick. I'm gonna make this smaller, and I'll draw it. Let's see here. Let's take it and just cut this here, and I'll copy it into a paint deal. that so we can draw on it. Here we go. So what you do is right here, you just take it, have this be the pot. And let's say that's a 250K pot right there.
Yeah.
And then you would take this cap here, and then you would put a resistor. Let's see, I'm gonna make this be a resistor. Here. And that resistor, let's see, they were tapping it at 70K on a 350K.
Right.
It's a 350K pot, isn't it?
It looks like it is. I can't really read it. I could never read it.
Yeah, it's a 350K pot. So if you used a, let's see, what's that ratio? 70 to 350. Let's see here. If it's a 350K pot, so
270.
Well, if it tapped at 70, the pot part's 280. So you could use
Right.
250K.
Okay. Right.
Use a
280.
250K. Use a 250K pot, which is a standard value.
Right.
Well, why is this not doing? Yeah, 250K pot, and then over here, maybe a 68K, which is standard value. Use that there, and then right here, this part here. Well, let's see. I'm gonna get the whole rest of this. And then you would just have this go to the junction. Like that.
Okay.
And that should get it pretty damn close.
Oh, right. But on the original schematic, the wiper goes down below that tap, right?
Yeah, you wouldn't be able to do that on this one.
Okay, so that you would just
But
lose a part of the function of what.
Yeah,
right, I got you.
Yeah, the treble wouldn't
right,
go down
no problem.
as far, but it would be damn close as far as the rest of the schematic.
But just one last question. That wiper, let's say the original thing at 350K tap, when the wiper goes all the way to the bottom, what's going on with it's coming over.
You're taking off all your highs and upper mids. When this is going down to, that's the wrong.
But
when this wiper's going down to here on the tapped version, then when your high end gets here, it sees that 0.005 is almost a direct short. The highs do, the lows don't.
All right.
So you lose all your high end there. I mean, it just kills it.
Right. But
which
there's a little bit of
resistance. I don't think you would want that setting anyway.
Right.
You know, turning the treble all the way off on a Fender amp, I don't think that's a good idea.
Yeah, of course, but when the wiper's all the way at the bottom there, you got a tiny bit of resistance at 70 taps, so a signal comes through there, hits a little bit of resistance, and then goes out the other wiper, right? Is that the idea? I'm just trying to understand why the
What
EV did this.
I don't see another wiper. Where's the other wiper?
The wiper, the treble pot wiper, when it goes all the way to the bottom, it's below that tap. So the signal coming through the tap has to go.
There's no signal going through the
resistance.
cap. There's no signal going through the cap.
Oh, okay.
The signal
It's coming from on top.
Yeah, the signal is coming in here, and your highs are going here. I need a thicker thing. You can't even see that. Okay, the signal's coming in here, and the highs are going here. You got highs there, and then the mids and lows are going here, like this. And this wiper is choosing between highs and not highs.
And lows, right.
Yeah.
Right.
And, but by having a tap pot, this can go even lower, in which case you're just filtering out more highs. But like I said, I don't know anybody that would use that setting. I mean,
I don't either.
You know, why would you want to turn the treble completely off on a Fender amp?
Right.
So, but there are people that are making these. I think maybe Bill Sheehan might have them.
Right.
Bill at Sheehan Enterprise. Yeah. Anybody else know of anybody else that sells these tapped pots?
Yeah, Amp Repair Parts has them.
Amp Repair Parts, yeah.
Yep.
There's a couple of places that might have them, but you know, you don't necessarily have to have them to make the amp work if you've got a problem with the pot. And most of the time, most of the time the pots can just be cleaned.
Right.
When you're doing an overhaul.
Right.
They're $5.
Okay. So
Thank you.
You're welcome. Anybody got any comments on this? Okay, well, that's all I've got on my queue tonight. We still got about 5 minutes. If anybody's got something they want to talk about, raise your hand and we'll unmute you.
Has anybody ever worked on a Silvertone metal